In section 4.5, we're going to talk about ratios and proportions. These are incredibly important ideas in math, and they're very useful for solving all kinds of mathematical problems, both in math classes and out in the world where you apply math. So we're going to start off simply talking about what ratios are, what proportions are, and then we're going to do some applications of these ideas. So these are just a couple of problems that we might do using ratios and proportions. The first one says David's car gets 27 miles per gallon. How many gallons of gas should he expect to use on a cross-country trip of 2,625 miles? And the second problem says a 50-pound bag of fertilizer will cover a 4,000 square foot lawn. If Lance has a 25,000 square feet of lawn, how much fertilizer will he need? So these involve relationships between two sets of numbers, and that's where this is going to be helpful. So first of all, we're going to just talk about writing ratios. So ratios look like, a ratio is a mathematical comparison of two numbers. And the way we write ratios is, this is the way we say ratios, and we can write them out that way in English. This is the ratio 19 to 1. And we can also write it out this way, 19 to 1 with that 2 becoming a colon. And then very frequently in math we write out ratios like a fraction, 19 to 1, like that. So all three of these are the same ratio, just written differently. So order makes all the difference in the world in writing a ratio. So this is one of the places where people have a little trouble sometimes. So be really careful about order. When there's an English phrase that we're using that's talking about the ratio, that's what will tell us what order the ratio needs to be in. So here it says if a second grade class had 7 boys and 12 girls, then the ratio of boys to girls. So this is what I mean by the English phrase is what governs the order of the ratio. This says the ratio of boys to girls would be, so we have 7 boys, 12 girls, so boys to girls looks like that, 7 to 12. And then like we said before, you could write that as 7 to 12 or 7 to 12 like this. So now if we talk about the ratio of girls to boys, that's different. So up here we had boys to girls, here we have girls to boys, so that's going to flip the order of our ratio. So it flips it to 12 to 7 instead of the 7 to 12 we had before, and that 12 to 7 can be written like that or like that. Now, you might say, you know, what difference does it make? It's a little, so it's switched in order. We can change the order of words and sentences all the time. It doesn't make a big difference. But it really matters a lot with ratios. Just if you look at these last two ways of saying that, think of those as fractions. Well, you know the fraction 7/12 is a lot different from the fraction 12/7. So it matters a lot what order you write the ratios in, so make sure you know how to write that ratio. The ratios can also be simplified like fractions. So if I had a ratio from a word problem that came out as 10 to 20, I wouldn't want to report it as 10 to 20. I would want to reduce it. And so if you don't remember how to reduce fractions, we find the biggest number that'll go into both the top and the bottom, and we divide them. So 10 divided by 10 is 1, 20 divided by 10 is 2. So 10/20ths would be reported as 1/2. And we do that for the same reason we always reduce fractions, is if we're going to do some work with these ratios, it's easier if the numbers are smaller, just the multiplications and divisions become smaller with smaller numbers. So try this one on your own before we go on to the next slide. So this one says, in 2010-2011, among students taking classes for credit at LBCC, there were 22 full-time students for every 33 part-time students. So A asks you what was the ratio of part-time to full-time students, and B asks what's the ratio of full-time to part-time students. So pause the video here and try this one on your own before you go on with the video. So let's do this one together. A says, what was the ratio of part-time to full-time students? So we have part-time to full-time students. So this one is going to be, so for A, part-time is 33, full-time is 22. So ratio of part-time to full-time is 33 to 22, or written like this, 33 to 22. So for B, it asks for the ratio of full-time to part-time. So for B, we're going to do our full-time number comes first, and then the part-time number comes next in this one. Order makes a big difference, so this is going to be expressed as 22 over 33. So if you get those backwards, everything goes wrong in a problem where we're using ratios to find answers to a word problem. So the ratio that we've talked about a ratio looking like this. So that's a ratio. Now we're going to talk about a proportion, and a proportion is when we set two ratios equal to each other. So it's an equation that says two ratios are equal. So here's one. If I write this out, I'm telling you that the ratio of 4 to 7 is the same as the ratio of 14 to 24.5. Now, a simpler version, I could tell you that 1/2 is equal to 2/4, or a ratio of 1 to 2 is equal to a ratio of 2 to 4. So that's a simple ratio, not the same ratio or proportion as this one, but this proportion says that the ratio of 4 to 7 is equal to the ratio of 14 to 24.5. And so that setting the two equal makes a proportion. And then if we want to see if I'm telling you the truth about that being a proportion, remember, if I say it's a proportion, it means that those two things are equal. And the way I check to see if they're equal is I do cross multiplication. So I want to see what is 7 times 14 equal, and then I'm going to check and see what 4 times 24.5 is, and I'm going to see if they're equal. And sure enough, if I were to do those multiplications, I'd find out that 7 times 14 is 98, and 4 times 24.5 is also 98. So that means that this is a true proportion. So that's the way you check a proportion. So given what we just learned about cross multiplication, that I could check a proportion to see whether it's a true proportion, think about how we might solve this proportion to see what the missing variable is. So pause the video for a second and just think about that before you watch me do it. So I want you to think about how we checked the proportions in the last one and see if that can help you figure out how to find x. So pause this and take a look at that for a second. So if you think about cross multiplying that we just talked about, what that means is if this is going to be a proportion, if I multiply these two together, it better give me the same answer as if I multiply these two together. Well, that just means 8x better be equal to 5 times 72, which would be 360. So I'm just saying the same thing as I did in the last slide about that if a proportion is equal, the two cross multiplications have to be equal. This time I'm using it to make an equation that I can then solve. So 8 times x equals 5 times 72. So then I'm going to solve that like I would any equation. And I got 8, or x equals 45, I think. So that means if I rewrote my proportion, it would say 5 over 8 is equal to 45 over 72. I want you to try one of these before we move on, so I want to make sure you know how to do this. So pause the video here, try this, and see if you can get a solution for it. Solve for y. So let's do this one together. So we're going to use our cross multiplication to find an equation. So this multiplied together should give me the same thing as this. So that means I've got 6 times y equals 13 times 9. So that means 6y is equal to, let's see, 90 plus 27, so 117. So I'm just multiplying 13 times 9. Then 6y equals 117, I'm going to divide both sides by 6. So y equals 117 sixths. This can actually be reduced, although I'll forgive you if that seems hard to reduce, but 3 goes into both of those, and so we get 39 halves of that. So remember, the point of that was to take a proportion that where we're missing something, we were missing that y, and we wanted to find it, and we had a proportional relationship, and so that allowed us to solve for y. So we're going to apply that concept in the next video.